Welcome everybody to today's Vision Energy webinar on maximizing project revenue with versatile batteries that deliver energy and power services. My name is Matt Barber with Mercom Capital Group, and I'll be the moderator for today's session, and I'll be introducing today's speaker. Just some quick housekeeping. No, your microphone is not broken. All attendees are mute to make sure that everybody can hear the presenter clearly. You can use your questions panel on the toolbar to type in questions at any time during today's session, but note that we won't be answering most of them until the end of the session, although if there's good ones that in correlation to certain slides, we may pull them out as we go. We are recording and have already started the recording, and we will send out a link to all registrants after the webinar. Today's presenter is Vision Energy's Vice President of Marketing, Mike Grunow. That's him in the picture there in the middle, just after he finished a triathlon that included swimming in Lake Michigan. I assume not this month. Mike has over 15 years of experience with businesses focused on deploying clean tech technology with companies such as General Electric, Trina Solar, Moventus, and now Vision Energy. Mike, the floor is all yours.
Hey, thanks a lot, Matt, and thank you everybody for coming, who's listening to the webinar live, and those of you who are listening it in the future on recording. Just a bit of an agenda today. We're going to spend probably 30 to 40 minutes talking first about versatility and how we like to define it here at Vision with respect to performance, power streams, flexibility, and other specific areas of focus. Additionally, we're going to look at a handful of use cases that are typically popular within at least our customer base, and a lot of articles that are discussing storage recently, and analyst reports as well, specific use cases and what kind of versatility they require for both utility scale, C&I, and microgrid. Lastly, this wouldn't be a Vision webinar if we didn't wrap it up with explaining how Vision systems work and how we perform across various applications and use cases and why we're unique with respect to our competition. So defining versatility, right? So I've been in storage now for 14 months, and like many of you, I came from a traditional power generation, wind and solar background, and this was one of the charts I'd seen on my first few weeks studying this industry. On the left, you can see that it, sort of takes a look at the 15 available or most popular different types of storage. It breaks them down into mechanical, electromechanical, electrical, pure thermal, and then it starts to look at the various columns at the short duration, medium duration, and longer duration applications. And you can quickly begin to see this concept of trying to theoretically match a single use case one-to-one with a particular type of storage technology. And I'd say, at least over the last 24 months, that you're beginning to see a similar correlation in early market applications, such as single service, behind the meter, demand charge management, or single service, front of the meter frequency regulation. We have a tightly correlated use case with a single service on one side of the meter that is locked in with the specifications of a particular storage technology, something that I like to call a one-trick pony. So we've all seen kind of the wheel of services, right? And if you hadn't, I apologize, it's an eye chart. But this wheel of services is pretty popular. It breaks it out into really three sections of the pie. Customer services on the upper left-hand side. These are sort of behind-the-meter services for energy storage. ISO, RTO, or wholesale services in the upper right-hand side. Things like arbitrage, frequency reg, voltage support. And then on the bottom, you see utility services, and these are mostly transmission and distribution deferral or congestion relief, right? And as you look at these, it's important to take these and go back to, the previous slide and then ask yourself, which of these is a power service meaning a short duration, high power application where the battery needs to be really cranking, or which of these is a long duration energy type charge with a slower charge rate where the battery has to be able to go from 0 to 100% state of charge over the course of 2.5 to 5 hours, right? So the E and the P are power and energy services. I've gone through and overlaid the vision perspective of the various services that batteries can provide, and you begin to see that power and energy are quickly defining the particular use cases. And when we get into the concept of stacking, right? So service stacking has been and will be, the key driver of storage project profitability, right? And a recent article just came out and said, the shave, shift, and shimmy is the key use case for commercial industrial energy storage, right? And so I'm highlighting 5 use cases, and frankly, we see these 5 services in a particular use case for behind-the-meter commercial industrial storage in PJM or California marketplaces on a pretty regular basis. So what am I talking about? We're talking about large industrial clients that use a lot of power, right? That want to deploy storage to do peak shaving, demand charge management, a power service. They also want to do a time of use service, such as buying power low and selling it high. That's an energy service. They have the opportunity to participate in wholesale services, depending on the ISO. So that would be a frequency regulation application. In addition, they oftentimes have solar because the ability to leverage the ITC and the maker's depreciation. So we call that the green charge. That's an energy service. And then resiliency. Not always a requirement, sometimes a requirement, but it's a perceived inherent capability of storage. 9 times out of 10, if the project doesn't have resiliency and it gets to the final approval table, somebody around the table says, this will be great. When the power goes down, we'll be ready to go. And everybody looks around and says, right? And it's not always the case. So a lot of little revenue streams, a lot of little saving streams add up to the returns that drive IRRs into the high teens and mid-20s if and when possible.
Hey, Mike, not to mess with your flow, but we have a couple of questions that I think are relevant to this slide and the previous one. They're asking, can one storage system deliver all of the services on the wheel? And I guess related, are most of the storage systems on the market today capable of providing all of these services?
Sure. So I think we're going to spend a lot of time talking about that in the third section when we talk about the vision value proposition. And both of those are good questions. I think as I alluded to in the first few slides, Matt, and whoever asked the question, a lot of times you have an engineered storage solution designed to meet either the energy services or the power services. And for different limitations, and particularly with respect to lithium-ion systems are typically either applicated for energy applications or power applications. And I guess if there's one key thing you take away from today's presentation, it's that the vision system is unique because it's able to stop as it's doing energy services and provide power services across the complete state of charge. I hope that answers the question. We'll touch on it a little bit more. So I'm going to spend the next 7 slides talking about specific use cases of storage deployed, and I'll be talking about the different benefits and services it can provide, and I'll be classifying those in terms of energy or power. But first, before I do that, I want to take a moment and pause and talk about what's happening right now in PJM, highlight it as a perfect example of the risks of moving forward with a project that only relies on a single service and is engineered and specified to tightly address the needs of an individual market and revenue stream. So we all know PJM frequency regulation. It's really a one-trick pony market, right? Over the past 3 to 4 years, nearly 400 megawatts of lithium-ion frequency regulation, single-service, front-of-the-meter batteries have been deployed to meet a 15-minute signal. Well, not too long ago, PJM suggested they want to move that signal to 30 minutes. And if you own one of those storage facilities, and all of them are merchant, except for maybe one that just went through a non-recourse project financing, if you own one, right now you basically have a choice if this signal is finally changed, because there's probably going to be a lawsuit and it's probably going to go to the FERC. But if you own one and the signal is changed, you really have a choice, right? You can derate the power of the batteries and run them for twice as long to meet the 30-minute signal and still get paid about half of the revenue you were otherwise planning on. Or you can run the battery full out, double time, and anticipate cutting its warranted life, by a major portion of the number of cycles that it has. So lots of IPPs are impacted. This is a key illustration of the risks in the marketplace that come with designing a storage project with a one-to-one match between a storage technology and a single revenue stream. And that's true basically wherever you look, right? So this is a chart that I love, right? And what it does is it takes the services that could be available on the wheel, and it organizes them by duration and frequency, and then it color codes them by customer site application, front of the meter, both sides of the meter. And all I basically want you to take away here is look at front of the meter, right? Front of the meter, you have opportunities for ancillary services and renewable smoothing in the upper left-hand corner. Those are short, frequent power applications. Then you have DR revenues and DG electricity sales that are more medium and long-term energy services. Same thing for the Royal Blue, customer-sided applications, right? Those range in terms of frequency and duration. And to maximize revenue, you really have to be able to participate in both the power, energy, low, high frequency, short, long duration signals that essentially drive savings and revenues and allow you to stack. So that was really looking at all of the front of the meter and behind the meter. It's also really important to talk about microgrids. Not enough discussion about microgrids, in my opinion. Microgrids are the single most demanding application for a battery, right? A great report came out last May. I've snagged and stolen a chart from it. You can see it here on the right. When a battery is part of a microgrid, right, which is a standalone island with its own generation and grid-forming services, it has a series of things it needs to do in terms of maintaining voltage and frequency and current and energy balancing, interacting with the diesel genset, interacting with whatever point sources of generation you have, whether they're wind or solar, inside, or even plug-in hybrid vehicles, plug-in electric vehicles, pardon me. The battery in a microgrid must be versatile to provide both the power and the energy services.
Hey, Mike, I had an interesting question here that you might want to touch on. Can storage work in conjunction with diesel generators in a microgrid?
No, that's a great question, Matt. And the answer is yes. So when you have a existing microgrid and you have a diesel generator, much like your car, a diesel generator wants to drive at a constant RPM. So you get better fuel mileage in your car when you're driving at 60 than you are when you're driving through the city, accelerating, stopping, and braking. And you could imagine that the actual load shape within a microgrid is very herky-jerky, right? You've got, various point sources of load. You've got man camps, you've got HVAC, you've got kitchens, you've got a bunch of different things that could be driving your demand. But the generator sort of wants to go at a constant RPM. If there's no storage in a microgrid, the generator kind of has to go through the cycles and match the overall power demand. And that impacts the generator in several ways. First of all, it really impacts the kilowatt hours per liter of fuel that you pump through the generator. In addition, it drives significant increases in generator O&M. So the first step to adding storage to a microgrid that already exists is dropping it in and letting the storage do the grid forming and let the generator run at constant RPM. Your generators will last twice as long and you'll burn less fuel. How much less fuel? It tends to vary anywhere from 7 to 15% less fuel. The other nice thing about adding storage is that once you add storage, you can drive renewable energy penetration into that application above 15 to 20%. And you can drive renewable energy penetration in a microgrid all the way up to 70 to 80% and cut your diesel usage by 70 to 80%. Shifting from the microgrid to the large industrial application, and for this illustration, we chose a wastewater treatment plant. What I'm trying to illustrate here is an actual case study for an actual project that we're working on. And this is a 1 megawatt storage system with a 1 megawatt PV system for a wastewater treatment plant in Southern California. This is on time of use energy 8 in SCE territory. And if you look at the chart, the IRR chart, I'm illustrating what happens as you add and you stack the 4 different services. It's really important also to note that we're adding power and energy services to get to a 21% IRR. So you start off with energy savings. That's the old time of use, buy low, sell high, right? That gets you to about 5% IRR. Then you add in the demand charge management, power service, that gets you to 16% IRR. Then you add in the CPP, which is a power service, again, that gets you to 19. And then the capacity bidding program, that's a long duration service that gets you all the way to 21. So versatility in power and energy are critical to drive project returns, and the ability of your energy storage to do both on the fly is also critical. So we've done microgrids, right? We've talked about C&I, we've talked about PJM, but let's get back to the California duck curve, right? This is the much maligned chart of what happens in the California ISO market as solar begins to penetrate. And above that, you know, is the typical storage is coming to save the day via charge and discharge profile. There's a couple things that I really want to highlight here. First, really impacting this system with storage is the 2 cycle per day application. It's a morning charge and discharge, and it's an evening charge and discharge, right? Additionally, you know, as you have massive fluctuations in power, you know, it's not widely talked about, but it's widely known within the utility community and in the development community that there's a major issue called cloud chop, right? As clouds drift, major cloud formations drift across significant solar farms, you see wild swings in power, voltage, and current, right? And the ability of the batteries to do this type of firming, this type of renewable integration, as well as bulk load shifting, is a power and energy service, right? So the batteries that are put in place, the most versatile batteries that are going to solve the most problems for the utilities, are the ones that can do and address and drive power across the complete state of charge. Now, what do I mean by driving power across the complete state of charge? Much like your phone, the battery is going to drift between 0 and 100% state of charge as it's doing sort of this bulk energy shift to address the duck curve. But you don't know when the clouds are coming. The clouds could come at 5% state of charge, 50 or 95% state of charge, or anywhere in between without a normal distribution. And so the batteries will create the most value if they're able to stop at any point in time across that state of charge and drive power.
Hey, Mike, before you move on, I had one question about this slide. It says 2 cycles there in red, but isn't 1 cycle a day the industry standard for storage systems?
No, that's a good question, and we'll talk to it a little bit later. Normally, what you have in a lithium-ion warranty, you have a situation where you're given a kilowatt-hour degradation curve, and that kilowatt-hour degradation curve is a function of daily cycles. And most battery warranties are given based on a 1 cycle per day. Now, batteries can do 2 cycles per day, but it will lead to accelerated degradation at the energy storage technology level. So we've talked about C&I. We just talked about utility scale. Here's another utility scale application that we're seeing become quite popular, and this is with cooperative and municipal utilities. So ever since the FERC ruling last winter, these entities are now allowed to contract for solar and storage services on their side of the distribution network, and outside of the relationships with their traditional generation and transmission companies. And so what we're seeing is a major upswing in the types of proposals where a third-party developer will come in and propose to drop in, let's say, a 10 to 20 megawatt solar system combined with a battery at a substation that's owned by the co-op, right? And the services are blended, right? The first thing they're going to do is they're going to shield the co-op from peak charges for transmission and demand that are assigned to them from the G&T company, right? They're essentially going to meet that demand and keep the overall load profile from the perspective of their billing G&T company flat, right? And those are both power services. In addition, in a lot of weak grids, far rural cooperatives, they have some significant challenges with respect to voltage support. So the batteries themselves can actually help maintain voltage and provide those types of grid services behind the substation. In addition, a lot of these co-ops have several different substations, and it just so happens that there's usually one due to load growth that is in trouble and would need to be upgraded with a significant capital expense in the next 5 to 10 years. And in terms of dropping in a storage system next to a solar farm at that location, the application is able to delay and defer the upgrade expense. So that's an energy service. In addition, it's easy to hardwire the battery in the storage system to something like a firehouse or a town hall. So if grid power goes down for any reason, that the community has a place where they can coalesce and use as an emergency shelter. And frankly, we're seeing quite a bit of this up in Vermont after some of the nasty storms they've had over the past 5 years. Lastly, as you're generating solar and selling it for less than brown power into the co-op, there is a rule that says that co-op is not allowed to backfeed any solar up into the transmission lines from the substation, and the battery prevents against that. Got a couple more of these. They're kind of fun. So everybody's talking about battery storage and peak capacity, right? And utility executives are coming out and say, we're never going to build another peaker. We're going to use storage, and everybody's talking about the versatility of storage. But I wanted to illustrate for this audience, the need for versatility within these peakers. The fact is that most peakers run with a capacity factor is less than 10%, right? So you got to ask yourself, if you're going to own one of these things, what do you do with the battery the other 90% of the time? And the primary answer and the primary trend that I'm seeing has to do with wholesale market opportunities. Now, some of those are power, but some of them are energy related. And the opportunity of for the battery to do both the peaker and the wholesale market participation gives you significantly more value. Two more, one on large-scale solar, one on large-scale wind, getting back into kind of the theme of the day, which is power and energy versatility. So what you're looking at here is your typical, let's call it 100 megawatt block of solar. And, you know, we've already talked about absorbing cloud shop and wholesale services from the battery. So those are power application. But the batteries can also increase capacity factors by allowing the overall, let's say, you would typically put, you know, 110 to 120 megawatts of DC solar on a 100 megawatt AC interconnect and 100 megawatt transformers and substation. With energy storage, you can drive that to 140 to 150 megawatts and 20 to 30 megawatts of batteries to drive more afternoon power. Just saw yesterday, it looks like Hawaii is going to come out with 2 different tariffs, and one set of tariffs for solar that's delivered between 5 and 10 p.m. So a time of use energy application combined with the power requirements of that we've illustrated here. Similar story in wind, right? We've got about 75 to 80 gigawatts of wind in North America alone, with more than that deployed in Europe. And, you know, the ability of those wind farms to start to participate in wholesale services and is significant. In addition, what I'm hearing from the development community is that the days of excellent low-cost interconnection are somewhat gone. You know, the best sites, the best lines, where the best winds are, where the population density is low and the fear of NIMBYism is low, are hard to come by in terms of obtaining land rights and options for easement and interconnection. And as they do grid interconnection studies on the sites they can get, you tend to find that the grid operator will come back and say, okay, if you want to put 50 megawatts of wind here, it's going to cost you $5 million. But if you want to put 150 megawatts, it's going to cost you $15, $20 million of grid upgrades, not just at the substation, but also upstream and downstream from your project. And so you begin to see these step curves. And what we're starting to see is developers of projects start to look at, okay, so what's my histogram of wind power output over 365 days in a year, or 87, 60 hours, and how do I then oversize the wind farm and add a battery and minimize the substation size so that I can drive down my interconnection costs? And it's an interesting analysis. Then the energy services come along, ramp rate control, curtailment. Curtailment, I obviously now that the CREZ lines are built in Texas, it's gone way down, but it was around 10 to 18% depending upon the farm. In India right now, we're seeing wind farms with up to 35% curtailment, right? So the ability to use that energy, charge the batteries, and discharge it later and participate in wholesale markets is a big opportunity.
And Mike, there's a question wanting to speak to the theme of the day, as you mentioned. What kinds of batteries are best suited for combinations of energy and power services?
Well, thank you for that one, because we are going to be transitioning into the portion of the presentation where I'm going to be talking about different types of batteries. Specifically, I'm going to be addressing vision batteries, and I'm going to be explaining how they perform in these applications that require power and energy, and I'll be juxtaposing that against lithium-ion, which is the most popular battery technology today, and we'll be talking about how vision and lithium-ion batteries differ in systems that require both power and energy. So without further ado, a couple slides on vision. For those of you who have not attended a previous webinar or met any of our commercial staffs, we've been around for almost 9 years. Everything that we produce is manufactured by Jabil. They're almost a $17 billion company. Our 80 patents and our ISO 9001 quality program are what has helped us with independent engineering firms like Black & Veatch and TUV to get third-party auditing of our technology and to help us essentially achieve bankability. Our first 80 megawatt hours of commitments are in place. We're quickly growing. This is going to be an excellent year for Vision in terms of deliveries and revenue growth, and our partners speak a lot about that. We're developing right now the largest flow battery system in North America up in Ontario. It's a 2 megawatt system with Hecate Energy. We've got a bunch of systems in the field, but a notable one with Idaho National Laboratory going through all of the microgrid certifications that they need for use in the Department of Defense applications. In addition, we have an excellent partnership with Schneider. So if you think about a storage system, the battery is like a big dumb DC block. Schneider Electric is our partner for everything else in terms of power conversion systems and controls. And lastly, all of the utilities or IPPs, developers, or commercial industrial customers, when they learn about Vision, they say, okay, I'd like a turnkey quote. And that's where our partners like Ryan, one of the largest EPC contractors in North America, and Alpha, a company with 40 years in energy storage, step in and provide turnkey quotes, including financing options and including operations and maintenance. This is the standard Vision product, right? It's a 1 megawatt, 4 megawatt hour building block, multiple deep cycles per day for 20 years. It can discharge for up to 4 hours at full power, or a third rated power for as long as 12 hours. So when you look at this chart, you might think, this is your standard flow energy battery. Got it, check, I understand what you guys are. But what really makes us different is this chart. So we have a white paper on this, and there's lots of write-up on this on our Black & Veatch report, which we're happy to share under NDA with anybody considering building a project. But what it says is we've simulated over 27 years of PJM cycling, up to almost 1.1 million cycles. And we've done these cycles from 10% to 90% state of charge with zero cell replacements and almost negligible impact on our overall capacity of the battery, right? This is pretty unique. This is pretty unique because if you did this with a lithium-ion battery, it would fade to roughly 50% in 5 to 7 years. And frankly, most of the flow batteries out there can't meet the requirements of the PJM Reg D cycle. So it's important. It's important to know that the Vision Energy System can provide short duration power services across the complete state of charge while it's providing energy services, not simultaneously, but at the same installation. We call it walking and chewing gum, right? As we're walking up and down providing an energy service, we can stop at any instance and provide the power service that the application needs. On the bottom is a chart you might recognize because it comes out of a pretty popular brochure from a leading lithium-ion module provider. And basically, when you buy a lithium-ion battery system, you have to choose at the beginning if you're going to buy a power or an energy application, if you're going to go for a short duration service or a long duration service.
Okay, Mike, sorry, before you go on, I have a question here, and I apologize for doing this, but I'm going to put you on the spot a little bit. Why can't lithium-ion systems perform energy and power in one system? Is a question we got a couple of times.
No, that's a great question. So I'm not a lithium-ion expert, but what I will say is their brochures are structured this way, and the duty cycles and the use case of an energy application and a power application are significantly different. And if you look at lithium-ion systems, they're typically complete with large HVAC or liquid cooling systems built into them. And power applications and energy applications have very different needs in terms of thermal extraction from the battery cells. And you could just imagine that the rate of airflow or the rate of coolant flowing over lithium-ion modules or lithium-ion cells is much higher for a high-power application than it is for a long-duration energy application. So these storage systems and their auxiliary cooling systems and HVAC systems all work together to make sure that you have a system that can meet the singular need. However, if you go and you run an energy system on a power application or a power system on an energy application for any significant amount of time, I'm told that you're going to either void your warranty or smoke your battery. So I've been saying this all day long, right? We once looked at this wheel. We said, okay, that's great, power and energy. What I'm telling you about the Vision battery is that we can do the whole wheel. Now, it wouldn't be a Vision presentation if I didn't talk about safety. What you're looking at here is, the standard stack up of various technologies that are pretty popular, different chemistries that are being compared. And, the Vision system is down at the bottom with a 200 NFPA rating versus the lithium-ion system in the upper right with the 322. This doesn't have anything to do with power and energy, but it has to do with the degrees of freedom that you're going to have with siting, permitting, insurance, transportation, and end-of-life treatment with your battery. All of those 5 aspects are important. I wouldn't call them power and energy versatility, but I would say they're important in terms of flexibility with your downstream project development efforts. So I don't know how many people on the phone have ever seen an image of a large-scale lithium-ion installation. There's one right up here in the upper left. What you'll see is that in addition to the containers, you have at the end of every container a power conversion system, and then you have the HVAC, right? These HVAC systems pump through insulated tubes into ducts throughout the containers, cooled air at rates that are driven by control systems that are looking at the internal ambient temperature and the surface level temperature of the cells and modules themselves. It's highly regulated. In warm climates, they can run 24/7, frankly, depending upon the use case and the duty cycle. And just one heads up, typically these AC loads, these HVAC loads, are never included in the round-trip efficiency calculations. In addition, as we talked about earlier, these are typically limited to 1 cycle a day. You have a lifetime of your cells. When they get the 50 to 60% nameplate rating, that's 7 to 10 years due to the capacity fade, which what we're hearing recently due to year 1 seasoning can be as high as 4 to 5% per year. You compare that to Vision, no HVAC loads. We're doing some systems in the Mojave. We've looked at projects in Kuwait. None of those systems with Vision would require HVAC. We don't limit folks by duty cycle. There are no cell replacements, and it's a 20-year firm capacity.
And Mike, while you're on that topic, this question has actually come up a few times already, but how is it possible that Vision systems can operate in extreme environments like the Middle East in summer without HVAC?
Sure. So the batteries themselves have a very wide operating temperature. So the round-trip efficiency of the battery does not have specific temperature ranges. And you can see here on the next slide, slide 27, where we are looking at 4 key categories that are typically called out in lithium-ion warranties. and the same requirements from a vision system. So row 2 here is looking at tight cell temperature ranges, right? So the vision temperature range is very wide and very flexible. And you compare that to lithium ion, where when you go outside of a certain cell temperature range, you start to see warranty penalties, and you have a much more flexible application. Same is true for state of charge, accumulated energy, and average charge and discharge power. We were recently talking to a controls company executive who's done a lot of business with lithium-ion systems, and they were applicating their control system to also work on a vision battery. And basically, they finished up in a few days out at our engineering headquarters, and over a beer, he was telling me that basically they just spent a few days deleting 85% of their code, because 85% of their code is dedicated to protecting the lithium-ion battery from burning itself up. So if you look at lithium-ion warranties, you'll start to see over 10 years, forecasted and guaranteed degradation for capacity. And, you're looking at, 3 different data points that are somewhat typical, at least in some of the literature we've seen, and things begin to evolve in and around warranties on a daily basis. And then you compare that to the vision warranty, right, in terms of capacity. And it's interesting because a lot of the applications that we're looking at are going to be non-recourse finance, are going to be part of a structured debt package, a debt solution that oftentimes has in it solar and wind. And you typically have 20-year structures. And a lot of the bankers and a lot of the developers are calling for storage systems with kilowatt-hour guarantees that go all the way out to the term of the debt that's equal to the term of either the wind farm or the operating life of the solar panels themselves. Last slide to sum it all up, right? We talked a lot about versatility today, versatility between power and energy applications. We looked at, I think, 8 different use cases where it's clear that the economic revenue streams are maximized by an energy storage system that can deliver power and energy applications for 20 years from a single platform. Obviously, safety is critical, because as we look at energy storage, it tends to create the most value when it can be at the edge of the grid. It turns out the edge of the grid is a place where there's a lot of people living, working, playing, as well as high-value substations and infrastructure. We didn't talk about it much today. I mentioned Black & Veatch, but my closing point is going to be an interesting nugget that we took out of the Black & Veatch report. And basically, after spending 6 months crawling over our factory, our technology, our field data, they came back and they concluded that they believe that our batteries outperform lithium-ion-based chemistries at high temperature, primarily driven by the HVAC loads and the lack of them. So with that, I'm going to end this and open it up for Q&A.
Thanks so much, Mike. Great job. That was all really interesting stuff. We've tried to touch on as many questions as we could during the presentation. I'm basically stalling right now to give people a chance to type real quick and get in their questions. We'll answer as many as we can right now during the webinar, but any we don't get to, we will contact you directly because the webinar does record all of the questions. So first one, Mike, talking about the electrolyte, is there any special gear required to perform the maintenance on the electrolyte?
Sure. So short answer, no. Basically, the electrolyte maintenance on a vision system is the moral equivalent of checking and adjusting the pH in your pool. So no special equipment. It's done on an annual basis, and it's just a balancing or polishing of the electrolyte and checking of the chemistry.
Very good. One question that's come up in multiple different forms, so I'll just kind of make it generic. What is your price like?
Sure. No, that's a good question. So there's a lot of confusion in terms of battery pricing because a lot of folks out there are just quoting module pricing, and that's like getting the price of a car with no tires and no engine, right? And what we'd rather talk about is turnkey pricing, right? Expected turnkey pricing from an EPC on a system for, let's say a 10 megawatt utility scale or a 1 megawatt behind the meter commercial industrial system. And what we've seen out of our partners, and that's why we have them, and we can reply quickly, is that our turnkey pricing is typically within 5 to 10%, sometimes lower, sometimes higher, as the turnkey pricing coming from lithium-ion system integrators. So we are very competitive on a first cost basis. And really where we win and how we're able to capture market share is because we're able to provide more services, right? Versatility, power and energy services, more income on the project level. We're able to do that at roughly twice the battery throughput every day because it's more cycles per day, more warranted cycles per day. And we're able to do it for twice as long, right? So 20 years versus a 10-year warranty really drives IRR and really helps us compete at the project level. If anybody's interested or wants to look at a specific project, we've got a great application engineering team that can look at your loads, size the battery, develop a budgetary first cost analysis, and a project 20-year pro forma, complete with IRR calculations and pretty graphs. We do that in about 36 hours, right? So email me after this call, and I will be happy to stick our commercial team on you and get you a competitive quote.
Thanks, Mike. This question is referring to one of the earlier slides about munis or co-ops. You mentioned deferring expenses would help to be able to pay for storage, but that's a really big ticket item for a muni or co-op. So how can they be confident that the system will last and they'll get the return on investment?
No, that's a good point, and I'll go back to that slide. I'm assuming you guys can see my my desktop. I've got the co-op slide, and that's a two-part answer, right? One is, are you guys bankable? How can I be sure that's going to last for 20 years? And the other is, how can the co-op be sure they're going to get their savings, right? And I'll address the easy one first, which is the second one, right? And so what we're seeing in terms of the co-op getting savings is we're seeing development partners come in, propose these systems to co-ops, and then have them be a financial offer, meaning a third-party owned system, right, where the benefits are monetized for the co-op by the owner of the hybrid battery solar system, right? So it's roughly zero out of pocket for, not roughly, it's exactly zero out of pocket for the co-op, and it's all upside for the co-op. The second question is, are you guys bankable? How do I know it's going to last 20 years? And so, yeah, the explanation goes this way. Vision, been around for 9 years, independently verified technology by both Black & Veatch and TUV, right? Two of the largest energy independent engineering companies in the world. Manufactured by Jabil, right? ISO 9001, and a excellent partner for manufacturing. They have significant resources that drive quality on our behalf, and a big portion of those were reviewed by Black & Veatch. In addition, you have our partner Schneider, who entered into this relationship with us after a significant amount of due diligence on the technology, right? They do, almost $40 billion of revenue every year. And, they're packaged with us on the site You combine that with turnkey execution by, $10 billion companies like Quanta, and frankly, we have been able to bring financial parties to the table to offer both debt, equity, and lease financing for these projects for customers. And we're finding that it's not a significant hurdle or a significant challenge to do so. So, any more questions, Matt, coming in? Matt, you may have gone on mute, my friend.
Yeah, Mike, a lot of the questions that we have left are probably going to require more of a one-on-one answer because they're more to specific use cases, from that person. So this might be a good place for us to wrap up for the day. And thank you, everybody, so much for coming.
Yeah, great. It's 1:53, so we've been rattling on for about 50 minutes. I really appreciate everybody coming. You're all going to get a videotape of this. And please shoot me an email if you have a project. We'd love to work with you guys, and we look forward to seeing you out there in the field. Have a great day.